Boston Dynamics just started production on its Atlas humanoid robot, a 6'2", 198-pound machine with 56 degrees of freedom, and the first units are shipping to Hyundai factories and Google DeepMind. The AI running inside it, DeepMind's Gemini Robotics Foundation models, the same class of AI that powers coding agents and language models, is now controlling a physical robot body in a real manufacturing plant. And that's just the first story. A few weeks later, Tesla rolled the first Cybercab off its Gigafactory Texas line, a production vehicle with no steering wheel and no pedals. 2 production lines, 2 very different machines, both crossing the same threshold, AI leaving the screen and entering the physical world. At CES 2026 in Las Vegas, Boston Dynamics unveiled the production-ready version of its all-electric Atlas humanoid robot. This is the robot that spent years going viral for doing backflips and parkour, but the production version is a fundamentally different machine. It stands 6 feet 2 inches tall, weighs 198 pounds, and has 56 degrees of freedom, meaning 56 independent axes of movement across its body. Its hands have tactile sensing in every finger and palm. It can instantly lift 110 pounds and sustain carrying loads of 66 pounds. Dual battery packs give it about 4 hours of operation, and when the batteries run low, Atlas swaps them autonomously in 3 minutes. The spent packs recharge in 90 minutes. Boston Dynamics General Manager Zach Jakowski called it, quote, the most production-friendly robot we've ever designed, noting that the team reduced the number of unique parts and made every component compatible with automotive supply chains. That compatibility matters because of who owns Boston Dynamics. Hyundai Motor Group, which acquired the company and has committed $26 billion to U.S. manufacturing, including a robotics factory designed to produce 30,000 Atlas units per year. All 2026 deployments are already fully committed. The first fleets shipped to 2 customers, Hyundai's Robotics Metaplant Application Center, where Atlas robots will begin sequencing tasks in Hyundai's manufacturing operations, and Google DeepMind. DeepMind CEO Demis Hassabis confirmed on X that the first Atlas units are shipping to Google, where they'll serve as test beds for what he called physical AI. The DeepMind partnership is particularly notable because Google originally owned Boston Dynamics. It acquired the company back in 2013 before selling it to SoftBank in 2017. Now nearly a decade later they're reunited. DeepMind is integrating its Gemini Robotics Foundation models directly into Atlas, giving the robot a cognitive architecture that splits into 2 systems, a System 1 layer handling real-time balance and motor control at high frequency, and a System 2 layer processing visual data for abstract task planning and reasoning. The significant thing about Atlas entering production is the convergence it represents. Foundation models, the same architecture behind large language models, coding agents and AI assistants, are now the cognitive layer controlling a physical robot in an industrial environment. DeepMind's Gemini robotics models give Atlas the ability to reason about tasks, interpret visual scenes, and plan multi-step actions. That's the same fundamental capability that lets a coding agent read a codebase and make changes across multiple files. Except now, instead of editing code, the AI is picking up car parts and sequencing assembly operations. Atlas can also learn from its environment and push what it learns to other Atlas units in a fleet. That means every robot operating in a Hyundai factory is potentially training every other robot. The learning compounds across the fleet. And then there's the design philosophy. Boston Dynamics deliberately chose not to make Atlas look human. Competitors like Figure and 1X are pursuing human mimicry, robots that look like people. Boston Dynamics went the opposite direction, designing what they call a superhumanoid aesthetic. The reasoning is practical. In a factory, you don't need a robot that looks reassuring. You need one that can reach farther, rotate joints past human limits, and operate in orientations a human body can't achieve. Those 56 degrees of freedom aren't just a spec. They let Atlas move in ways no human worker can replicate. The timeline to watch is this. Atlas robots trained at Hyundai's Robotics Metaplant will start performing sequencing tasks at Hyundai's manufacturing operations by 2028, with more complex assembly work beginning by 2030. Additional customers beyond Hyundai and Google are expected to start receiving Atlas units in early 2027. Meanwhile, Hyundai's planned robotics factory aims to scale to 30,000 units per year. That production capacity number will be the real test of whether humanoid robots go from pilot programs to an actual industrial workforce. So Boston Dynamics is putting AI into humanoid robot bodies and shipping them to factories. On the other side of the country, at Gigafactory, Texas, another production line just crossed its own milestone. Except this one isn't building robots that work in factories. It's building robots that replace drivers on public roads. And this one doesn't have a steering wheel. On February 17, 2026, the first Tesla Cybercab rolled off the production line at Gigafactory, Texas. Tesla posted a photo on X with a simple caption, "First Cybercab off the production line at Giga, Texas." The vehicle in the photo has butterfly doors, 2 passenger seats, and notably no steering wheel and no pedals. This is a production vehicle that literally cannot be driven by a human. The Cybercab is a purpose-built autonomous taxi. 2 passengers, a 35 kilowatt-hour battery providing about 200 miles of range, and inductive charging, meaning it charges wirelessly, no plug required. It uses Tesla's camera-based full self-driving system with no LiDAR. The starting price is confirmed at under $30,000. Elon Musk announced on X that volume production begins in April 2026, though he cautioned that ramp-up under Tesla's new manufacturing process would be, in his words, agonizingly slow at first. That manufacturing process is something Tesla calls unboxed production. Instead of a traditional linear assembly line, where a car moves from station to station, Tesla builds separate modules in different areas of the factory and brings them together for final assembly. Musk has compared it to consumer electronics production and cited a target cycle rate of 1 unit every 10 seconds. Drone footage from Gigafactory, Texas, shows the ramp is moving. 6 Cybercab units were spotted simultaneously at the factory's crash testing facility, undergoing the validation testing required before volume production. Those crash test units visibly lack steering wheels, confirming that Tesla is testing the no human controls configuration, not a compromise version. The $30,000 price point is strategically important. Tesla's existing vehicles, the Model 3, Model Y, Model S and Model X, are consumer cars that people buy and drive. The Cybercab is different. No one buys a Cybercab to drive it. It exists solely as an autonomous vehicle, designed to operate in a fleet, picking up and dropping off passengers without any human involvement at any point in the journey. A production car with 0 human controls is a concrete milestone, regardless of where you stand on Tesla or autonomous driving. Every other autonomous vehicle program, Waymo, Cruise, Zoox, has retrofitted existing vehicle designs or built prototypes. Tesla is now manufacturing a purpose-built autonomous vehicle on a production line at a price point designed for volume. But the 10-second per unit manufacturing target reveals something people aren't talking about enough. The hard problem with autonomous vehicles isn't just the software, it's manufacturing the hardware fast enough to deploy at scale. Building one autonomous car is an engineering problem. Building thousands per week is a manufacturing problem, and those are very different disciplines. Tesla's unboxed production method is itself an experiment in robotic scale manufacturing. That said, significant obstacles remain. Musk has acknowledged that Tesla needs roughly 10 billion miles of driving data to achieve safe, unsupervised self-driving. Tesla's robo-taxi pilot in Austin, using Model Y vehicles, has logged about 800,000 cumulative miles with approximately 14 reported crashes, 1 crash every 57,000 miles. The average human driver crashes about once every 200,000 miles. Tesla also needs federal regulatory exemptions, because current U.S. safety standards require steering wheels, and the Cybercab trademark itself is still in legal dispute with a deadline of March 14 to resolve a squatter's claim. April 2026 is when volume production is supposed to begin, but watch the crash testing and regulatory track more closely than the production numbers. Tesla has confirmed it has a Plan B, shipping Cybercabs with a steering wheel and pedals if regulators require it. Whether the first Cybercabs that reach customers have human controls or not, will tell you a lot about how fast autonomy regulations are actually moving. And keep an eye on that 10 billion mile data threshold. Tesla's projected to cross it around July 2026, which would put software readiness and production ramp on a collision course right around the same time. 2 production lines, 2 very different machines, 1 shared reality. AI systems are now being manufactured at industrial scale. The question that matters going forward isn't whether AI can control physical systems. That's been answered. The question is how fast the factories can build them. If you want to keep up with where AI meets the physical world, subscribe, We cover this every day. See you in the next one.